Hello everyone, my name is Guus Vorst and I'm a PhD student at Amsterdam UMC at the Department of Child Neurology. So we can divide the brain into different sections. We are often interested in the volumes of these sections. Now we cannot compare these directly between people because we know people are different head sizes and brain sizes. So we often account for this by using normalization. So say we want to look at the thalamus in orange here. We can divide its volume by something called the ICV, or the intracranial volume, which is the entire volume inside the skull. In this case, the thalamus is 1% of the ICV. Now, something interesting that we saw on MRI scans of our patients was that they had very thick skulls. And this raised some questions to us. Could there be skull thickening? And if so, could the skull grow into the ICV? Because if that would be the case, it would be worrisome. Because if we now have a shrinkage of both thalamus and ICV, we would still calculate 1%, while the thalamus actually shrunk over time. So, therefore, we decided to look at skull thickness and ICV over time in multiple subjects, controls, MLD, and MS. And when we look at the change for one subject over time, which we subdivided into young and adult group, both our controls and MLD groups show skull thickening over time, which is normal. However, when we look at our adults, we see that the controls are around 0, while MLD and MS show skull thickening over time actually. Now, when we look at the ICV, in our younger subjects, we see something very interesting. While the ICV is growing over time in controls, we see that the opposite is happening in MLD. And when we look at adults, there seems to be some shrinkage in controls, but more in MLD and MS. So, this tells us that while the skull is thickening over time, it's growing into the ICV, and the ICV is shrinking. Now, the cause of this is not known yet, but we should be very aware of this because it may affect our normalization. Thank you for your attention.